welcome back to my channel Learn with Nikhil. So today we are going to test and build the Zener voltage regulator circuit. So in this practical, this is the circuit diagram given. So in the circuit diagram, we have input voltage or the input power supply as V in. Then positive is connected to a resistor. This is the input resistor that is denoted by RS. Then in series we have attached a milliammeter. Milliammeter is denoted as IS, that is the input current. Then we have a milliammeter attached, which is attached to a Zener diode. So this Zener diode is attached in the circuit and the current passing through the Zener diode is measured here, and this milliammeter is called as IZ. So this is the current IZ passing through the Zener diode. Next you have the output. Output current is denoted by IL and the output resistance is denoted by RL. L is denoted as load. So this is load resistance, this is load current. And finally the output which we get, that is the Zener voltage output, or it is denoted as VZ, or somewhere it will be denoted as V out. So this is the whole circuit setup. Now we'll make this circuit in this Tinkercad 3D software. So we'll click on create new circuit. First we'll change the name, Zener voltage regulator. Now in this Zener voltage regulator, the circuit diagram, we have to calculate the line voltage and the load voltage. So these two calculations we have to do. According to that, we have this observation table where we have to calculate the line regulation and the load regulation. So for calculating the line regulation, we have to vary the input, that is V in, while keeping the output, that is RL, constant. So we have to keep the RL constant. So if we keep the RL constant, this IL current will remain constant. So if we keep this output constant, and you have to vary the input, and we have to measure the VZ, that is the Zener voltage. And in load regulation, you have to keep the input constant, you have to vary the current, output current, and you have to measure the output voltage, that is Zener voltage. So in load regulation, you have to keep the input constant. So our input will be constant. We have to vary the current. You can vary the current through this resistor. So here we'll attach a variable resistor. We'll change this resistor, variable resistor, will change the current, and we'll measure the VZ, that is output voltage. Now let's begin with constructing this circuit. So first we'll take a breadboard. We'll require a Zener diode. We'll require a resistor. We'll require two resistors. We'll require an input power supply. We'll require a multimeter to measure the ampere and the voltage. So we'll require 3 milliammeters, and you will require one voltmeter for measuring the output voltage. So I'll convert this into ampere. We'll require 3 milliammeters and 1 voltmeter. Now according to this, Now first we'll start with the connections. We'll attach the Zener diode here. As per the circuit, the negative is on the upper side, positive is attached to the ground. So according to this, I'll rotate this. Negative is upward, positive I'll attach to this ground. This will be my common ground. Make this ground color as black. Now first, positive is attached to a resistor RS. So this resistor I'll attach it here. The value of the resistor, I'll keep it 1 kilo ohms. So the positive of the power supply is attached to the resistor. So this is the positive of power supply. I'll attach it to the resistor. Keep this color red. Then other terminal of the resistor is attached to the milliammeter, that is IS, to the positive of the milliammeter. So the other terminal is attached to the positive of milliammeter. Now next, the negative terminal, as you can see, the negative terminal of the milliammeter is attached to the positive terminal of IZ milliammeter. So negative is attached to the positive of other milliammeter. So this negative is attached to the positive of other milliammeter. This is IZ. And then negative of this milliammeter is attached to the negative of Zener diode. So negative of this is attached to the negative terminal of Zener diode. This terminal we have already grounded. Now the positive terminal of this milliammeter is attached to the positive terminal of IL. The positive terminal of this milliammeter is attached to the positive terminal of IL. For reference, you can just write the names down here earlier. This is VS. This is IS. This is IZ. IZ. This is IL. Finally, this is IL, that is load current. So this positive is connected to positive, negative is connected to the resistor RL. So negative, I'm keeping this resistor here. Negative is connected the resistor RL. Then the other terminal of resistor is grounded. And finally, you have to measure the VZ, that is the output voltage, which will be across this resistor RL. So I'll keep the voltmeter here. Across the resistor, you can take this positive terminal, negative terminal will be grounded. This resistor will keep the value as 2 kilo ohms. This value is 1 kilo ohms. This terminal remaining is grounded. Before moving, this is the final. This is VZ, that is the output voltage. You can call VZ or output voltage Vout, anything you can say. As per the circuit diagram, it is VZ. Now how to take the readings? First, this is line voltage. So for line voltage, as you know, the output RL, we have to keep it constant. as per the observation table, you know RL is constant and you have to vary the input voltage. Now here we have already kept the RL as constant. RL is constant at 2 kilo ohms. So RL is constant, so this current is also constant. Now we have to vary the input voltage. Now to vary the input voltage, we'll vary it from 0, 1, 2, 3, 4, 5, 6, 7, 8 till 9. 0 to 9 will vary the input voltage and will measure the output voltage. So to begin, we'll start the simulation. Input voltage is 0. When the input voltage is 0, all your every current and voltage, everything is 0. So here the output voltage will be 0. Take this center. Then for 1 volts, you can vary this from this bar also, or you can write it directly here. If you click, this window will pop up. You can write it here 1. So this will be 1000 millivolts, which is 1 volt. So for 1 volts, you are getting the VZ value as 667 millivolts. So this is 0.6 volts. I'll just write till 1 digit, 0.6 volts, or you can maximum write till 2 digit, but it doesn't matter, 1 digit is fine. Now next, I'll vary this to 2 volts, input to 2 volts. The VZ value is increasing, it is now 1.33 volts. So for 2 volts, it is 1.33 volts. As you can see, there is a drastic change, the increase in the voltage as there is the increase in the input voltage. Next, the voltage is 3, VZ value is 2, so 2 volts. Then 4, VZ value is 2.67. Now one thing I forgot to mention, the Zener voltage, we have kept the Zener voltage as 5.1 volts and 5 volts. So this is the Zener voltage. So as you know, after 5 volts, this voltage will get constant, as that's the purpose of the Zener diode. So 4 volts input, the VZ is 2.67. Now when the input supply voltage is 5, output is 3.33. Now when we are applying 6 volts, the VZ value is 4. Now for 6, we have got the value as 4 volts. Now for 7, when input is 7, output voltage VZ is 4.67. 4.67. Then for voltage 8, now this is 5.1. Now when it hits this 5.1 volts, this is the Zener voltage. Now after this, the voltage will remain constant. It will increase but minutely. As you can see, from 0 to 8, it has increased drastically. Now after this, even if we increase input voltage, it will remain constant between 5 volts. Now for 9 volts, this is 5.2. As you can see, now it is increasing very slightly, it is increasing. If I extend this table, I'll just extend this table. I'll take the readings till 15. I'll just show you. Now when the input voltage is 10, see, this is 5.29. So I'll just write it 5.2. When this is 11, this is 5.3. It is increasing very lightly. It is between this 5 volts only, as the Zener voltage is 5 volts. 5.1. We have considered Zener voltage as 5.1. Then 12. This is 5.4. Then 13. 5.4 again. Finally 14. This is 5.5. So as you can see, after the 5.1 volt, this is remaining constant. This part is remaining constant at 5 volts. So if you are using the Zener diode of 5 volts, this is how the reading will be. If in case you are using the Zener diode of 9 volts, you are considering 9 volt Zener diode. If I start the simulation, as you can see, the voltage is, I'm increasing the voltage, the VZ voltage is increasing, and after 9 volts it is slightly increasing. So after 9 volts, even if I am increasing, it remains around 9 volts only. So this is how the Zener diode works. This is the function of Zener diode. So whatever value of Zener diode you are using, the output voltage will be constant at that. So 5.1 Zener diode voltage, so output will remain constant at 5 volts. Now this was all about line regulation. Now we'll move towards load regulation. Now for load regulation, we need to vary the RL voltage and we have to keep the V in as constant. Now to vary the output voltage or the resistor, we have to attach a variable resistor here. So I'll just remove this. I'll get a variable resistor. As a potentiometer. I'm considering the potentiometer as a variable resistor. I'll attach one terminal of the potentiometer here, and the other end or the wiper end, I'll attach it here, or you can attach this directly to ground. Now with this I can vary. I'll keep this at around 2 kilo ohms, and I'll keep this resistance now at 500 ohms. Now to start with the simulation of load regulation, we'll vary this voltage again from 0 to 10. So 0 to 10 will vary the load current and will measure the output voltage. So keeping the input constant and varying the load current. For varying the load current, now we'll change the potentiometer value. So first we'll keep this at constant. This is constant at 10 volts. So this we have changed, we have kept it at 10 volts constant, and we'll vary the resistance. Now this is the maximum side. This is 2.77 milliamperes. So this is how the resistance works. This is the maximum value of the resistance. So current is minimum. This is the, if I rotate this, this is the lowest side of the resistance. So this is the maximum current. I am varying it, as you can notice in the VZ. Even if I am varying, the voltage across the Zener diode is at 5 volts only. However, I'll less it down or increase, it is around 5 volts only. So this is the reading. We'll get this 5 volts only here. Okay, because the output is constant at 5 volts. If I vary the load current, keeping the input constant. Now maximum, this is 2.77. So I'll consider this directly from this. I'll consider this as 2 volts. 2 volts we have 5.5. 3 volts. 5.5, then 4 volts, consider this 5.4, then 5 volts, vary this, this 5 volts, we have 5.4, then 6 volts. As you can see, I am changing this 6 volts, 6 milliamperes. This is 5.36, 5.3, then reducing the resistance. This is 7 milliamperes, 7 milliamperes. You have 5.2 voltage, 8 milliamperes, changing this resistance, 8 milliamperes, 5.2. As you can see, it is constant at 5.2, 5.1. And for 9 and 10, if you see, it is 5.1 and 5.1. For 9 and 10, it is 5.1, 5. So this is the reading of the load regulation, and this is the reading for line regulation. Now with this reading, we will plot the graph. Now first we will plot the graph for line regulation. So on x-axis will be the input voltage, that is V in, and on the y-axis will be the output voltage Vz. So just giving the title, line regulation. Now to start with the graph, this will be the point 0 axis. Here will be the x-axis, that is input voltage V in. So you have to mention it. Here will be the output voltage Vz, that is also in volts. Just mention it here. Output voltage, and here input voltage. Now on x-axis we'll mark the points from 0 to 14, 0, 1 with a distance of 1 centimeter. And 14 is the last one. And on the y-axis with a distance of 2 centimeter, we'll mark the points as 1, 2, 3, 4, 5 and 6. Now we have to start plotting the points. For 0 it is 0, for 1 it is 0.6, this is 0.5, and 2 bits above it is 0.6. Then for 1, 1.33, so here it is 1.33. Then next for 3 it is 2, for 4 it is 2.67, so you can mark it at 2.6. Then for 5 it is 3.3, this is 3. Then you have to count a bit of 2 bits, so 2 bits is 1. So according to that, mark all the points. For 7 it is 4.6. Then for 8 it is 5.1. So from 8 you can notice the output voltage remains constant. It is around 5.1, 5.2. So this is the voltage, Zener voltage. We had considered 5.1 volts of Zener, due to which the output voltage remains constant after 5.1. So this is the constant line. After this, join all these points. And with this, we have plotted the graph for line regulation of Zener. Now just writing the scale, it is very important. Scale will be on x-axis. It is 1 centimeter is equal to 1 volts. And on y-axis, it is 2 centimeter is equal to 1 volts. And with this, we are done with the graph of line regulation. Next, we'll move to draw the graph for load regulation. So in load regulation, the graph is load current versus output voltage. So on x-axis, we are going to consider load current, and on y-axis, we are going to consider output voltage. So this is the starting point. On x-axis, we are considering load current, that is IL, and it is in milliamperes. And on y-axis, we are considering output voltage, that is Vz, or it is also called as output across Zener. Now we'll start marking the points. On x-axis, it will be 1 centimeter is equal to 1 milliamperes. So 0, 1, 2, 3, 4 till 10. And on y-axis again 2 centimeter will be 1 volts. So here I'll mark 1 volts, 2 volts, 3, 4, 5 and 6. Now according to the graph, first 2 points we have not plotted, but it will be at 5.5 volts only. We'll start marking from 2 milliamperes, that is 5.5, 3 milliamperes, it is 5.5, 4 milliamperes, it is 5.4, so it will be downward. Then again 5.4, then for 6 milliamperes it is 5.3, then for 7 milliamperes it is 5.2, 8 milliamperes 5.2, 9 and 10 milliamperes it is 5.1 and 5.1 respectively. So as you can see, this is almost a straight line. We'll join all these points. As you can see, the output voltage is constant. As the Zener voltage is 5.1, the output voltage is constant at 5 volts. Marking of the scale. X-axis 1 centimeter is equal to 1 milliamperes, and on y-axis 2 centimeter is equal to 1 volts. And with this we are done with the graph also. Thank you for watching. Do subscribe to my channel. If you have any doubts, any queries, let me know in the comment section. You can also connect with me on Instagram.